Hi, my name is Craig Honeycutt here at the University of South Florida in Tampa, Florida, and this is our 6th degree of freedom robot arm for robotics class. The basic construction of it, this is a 3/4 inch wood base with PVC pipe for the first revolute joint, and the rest of it we have access to a laser cutter, so we made it out of 1/4 inch acrylic. You can see the coordinate frames here at the base, blue being Z, red being X, and green being Y. So we have our coordinate frames at each link. And the basic motion of the robot, the first joint is a revolute joint. The second is a revolute joint about this axis. There's another revolute joint about this axis. Our fourth link is our prismatic joint. It goes in and out. And then we have our fifth revolute joint here at the bottom. And finally our sixth revolute joint at the end. So this gives the end effector a complete range of motion and 6 degrees of freedom. And here's our demo object. It's a cube with Velcro on both sides. We're going to try to pick it up here. Alright, got it. As you can see. Thank you.
Hi, my name is John Sushko, and this is the MATLab demonstration of our 6th degree of freedom robot arm that Craig just showed you. So what happens is, you run it, and it asks you to input either a transformation matrix for your initial and final position, or 3 X, Y, and Z positions for initial and final. So we're just going to do the easy way and go with the positions. So we'll call our initial X value 22, Y value -11, and Z value will go 21. Alright, and then it checks to make sure those are within the workspace. And now let's do our final values of 19. We'll do actually -15, 12, and 19. And now this is going from our initial ready state position, which we defined, to the initial, which we defined earlier, to the actual initial position of what we just put in the system. And once it gets there, it doesn't pass through any singularities. And now it's going from that initial position to the final position we input just a second ago. And it's swinging around. Oh, that would be a singularity. It passed through. And bam. And these are some of the parameter figures, and if you look at this one, this is the determinant of the Jacobian, and if you look right here, it does cross 0, so that means it went through a singularity. But it's still accurate enough that if we tell it to output our final transformation matrix, it still went to the exact value we wanted it to, at -15, 12, 19. Here, pull back a little bit. See, that's the value we told it to go to, and that's the value it went to. So even though it still went through the singularity, it still works fine. Thank you.